So the question asked was, I was confused by the part that said for square roots, consider if there are any reflections that would make k negative. Then use k equals 1 or k equals negative 1 and solve for a using a point. So if you look at the side notes that I've added, so there are two ways to find your a value. So one easy way is to look at the step that has changed between the original parent function to the transformed function. So the original goes up by a equals 1, but the red transformed function goes down by -2. So more accurately, there's a reflection along the x-axis, and that's why there's a negative, and there's a vertical stretch by 2, and so therefore a is equal to -2. So that's method 1. For method 2, what it's saying is that, remember, A and K are both talking about either the vertical stretch or the horizontal compression. It is making changes to the size of the parent function. So the strategy that they're presenting is that if we try to make the K a certain value, well, think of the original parent function. Is there a reflection along the y-axis from going from the black function to the red transform function? Well, K tells you if there's a reflection along the y-axis, and there is no reflection along the y-axis, right? And if there's a reflection along the y-axis, the graph will look something like this, and it would go that way. And so, because there is no reflection along the y-axis, I can say that k is equal to 1. So to say that there is no reflection on the y-axis, and then find your a value, the vertical stretch or compression, the a value accordingly. And so this is the transformed function. We got to fill in the values that we know. So we're going to plug in k equals 1 since there is no reflection along the y-axis. And then we have a d value of, well, it went down left by 3. So d is equal to -3. We're going to plug that in. And for c, it is going down 1. So c is equal to -1. And we plug it into the respective formula accordingly. And when we do that, we notice that the a and the x and the y are the variables that are not filled. And when we have that situation, we can plug in any coordinate that is on the red graph, almost any coordinate on the red graph. And in this case, I'm going to plug in the -2 comma -3. The reason I can't plug in the -3 comma -1 is when I do that, I'm going to find that this whole part cancels out because that would equal 0 and that would make the a 0. So that would get messy. So I'm going to plug in a coordinate and another coordinate. And when I do that, I will get this equation. And the a is solvable now. You're going to simplify and solve for a. And in both cases, you're getting a equals -2.